Okay, let's go over it very quickly. The retest will be next Tuesday before school in this very room in which we are now sitting, next Tuesday. Remember that the multiple choice again is all short answer. Same questions, all short answer though. So now there's a higher burden of proof. And then on the back, it'll be the same type of function. I've just changed the numbers a little bit, okay? So they're not those numbers, all right? And if you want to take it and score above 70 by any amount, we will replace your lower grade with a 70. Of course, if you made above a 70 and you want to retest because, you know, you like that, then feel free to do that. And if you do really, really well on that, I've been known to kind of shine some points on a grade here or there for going above and beyond. Okay, letter 1. We have log base 2 is 7, log base 11 is 9, log. So this is the one where you put everything in terms of natural log using the change of base formula. Natural log of 7 over natural log of 2 times natural log of 9 over natural log of 11, natural log of 2 over natural log of 7, natural log of 6 over natural log of 9. You do that, and then you have like factors that divides out. Your natural log of 7s, natural log of 9s, natural log of 2s. And you're left with the natural log of 6 over the natural log of 11. And that is an answer choice. It's answer choice D, okay? That was not supposed to be typed up like that. Mrs. Lincoln typed it up inadvertently like that, but that was a correct answer. We were trying to get y'all to then use the change of base formula one last time and put it back as log base 11 of 6, right? It works the other way around. The 11 in the bottom becomes the base, the 6 in the top becomes the argument. And that was answer choice C. So anyway, this is what she intended to type up for part D. The natural log of 6 divided by 11. Is that the same as the natural log of 6 over the natural log of 11? No. But many, many, many people inadvertently think that these two are equal, and they're not. All done? Thank you. They're not equal, okay? So anyway, it turns out that there were two correct answers, and you could have had either C or D or D or C or just C or just D or both, okay? So in general, you don't want to give two answers, right? If you were like, oh, I know there are two answers, and you put like C or E. Now it's like, oh, man, now you got it wrong, okay? Any comments or questions on number 1? Number 1. What's that?
So you did get that one right, and could have been correct.
What? No. Let me see. No, let me see. Did I grade yours wrong? Huh? No, you got credit for it. Yeah, you got credit for it. Yeah, okay. Number 2. Number 2 is the one that was the woolly booger. Okay? So you got to take the natural log of both sides and expand it out. So you get the natural log of 3 on the left. The multiplication turns into a plus sign, and then we get the natural log of 4 to the x minus third power. But the x minus 3 can slide out front in parentheses. Okay? So that takes care of that side. On the right side, a little bit easier. There's only one factor, so it's just the natural log of 6 to the 3x minus 1. And then the 3x minus 1 in parentheses can slide to the front. So anyway, that takes care of the first line. All done? Yeah, okay, thank you. Oh, yeah, there it is. Okay. We had it up for sale on eBay, but no one bought it. So we'll take the ad down. Yeah, see you. Okay, yeah, Craigslist. What did I say? eBay? Craigslist. Yeah. Do you use Craigslist over eBay? Oh, okay. All right, cool. Yeah. Okay, so now we carefully distribute, right? Carefully distribute the natural log of 4 into the x minus 3, and we get the line below. Remember, try to put the x's in front, because x ln of 4 is very different than natural log of 4x. It looks different. And then we carefully distribute on the right-hand side, 3x natural log of 6 minus natural log of 6, and that gets us to this line right here. Gets us to this line. So now you need to collect your x term. So here's an x term, and there's an x term. I went ahead and collected those on the left. So x ln of 4 is already on the left, and now I brought the 3x ln of 6 to the left side, changed its sign to minus. Everything that is not underlined then gets moved to the right-hand side. So I moved the 3 natural log of 4 over first because it was negative, so now it's positive. The positive natural log of 3 comes across, and now it's negative. And of course, they're joined over there by negative natural log of 6. All right, so that takes us to this line. Once you get everything separated, x is on one side, non-x is on the other, now it's time to factor out the x. So that's the line below. I pulled out the x, ln of 4 minus 3 ln of 6, and the right side is just patiently waiting. Okay, so now that I have x times a quantity, all I got to do is divide both sides by this quantity. Oops, that kind of makes it obscured. There it is. And then I end up with the right side, 3 ln of 4 minus ln of 3 minus ln of 6, all over ln of 4 minus 3 ln of 6. And you're like, I'm done. And you look to see if that's an answer choice. And it's not. So you get to play. Right. So what can we do? Well, if you preview your answer choices, you see some of them have an 18 in there. So here's what I would do. I would factor out the negative from both of those terms. Okay? And that's this line here. Notice when you factor out the negative, it becomes positive ln of 3, positive ln of 6, which means this can combine to give us what? Natural log of 18, 6 times 3, and then the negative would stay out front, okay? And so that looks like that. So it becomes 3 ln of 4 minus natural log of 18. In the bottom, I don't think I did anything yet, okay? So that would be a possible answer. Is that an answer choice? Well, no, but it's looking close. So if you look at some of the other answer choices on the bottom, they have the 3 ln of 6, but they don't have the ln of 4. So what can I do with the natural log of 4? Well, we did that one in class. The natural log of 4 is the same as the natural log of 2 squared, and then you could bring the 2 out front, 2 natural log of 2. So that's what I did. And that gets us in this format here, okay? And if you look carefully, that is answer choice D. Now, word of caution, because some people ran into this. If you were to collect your x's on the right side and numbers on the left, you would get the opposite answer. So if that ever happens, just multiply by -1 over -1. And what that does is it changes everything around, and it gives you this answer down below here. Okay, every sign in the top and bottom change. Okay, but they're equivalent. All right, so that one was kind of fun because I did mask 2 of the answers. I played around with the 18 in the top and then the natural log of 4 in the bottom. All right. Comments or questions on that one? If you take the retest, you don't have to play at the end, okay, because there's no target to hit. If you take the retest, you could stop as soon as you saw for X like that. You don't have to keep going, unless you want to, right? You're so well trained at playing, you just can't help yourself. Okay, any comments on that one? Any questions on that one? Okay, letter 3. Which of the following is equivalent to 1 over 7 to the x? Now this one, Mrs. Lincoln didn't even like shuffle the question answer choices around, so it was they were kind of in the same order as they were on the previous test, right? And so if you did that, it ended up being the same answer choice D. But let's see why. 1/7 to the x is exponential decay. If you come over here and look at G, that's the inverse of 1/7 to the x. That's logarithmic decay, base 1/7. So an inverse cannot be the same as the inverse, okay? So that's not it. This one, log base 7 of 7 to the negative x, well, that simplifies down to negative x. That's linear with a negative slope, so that's not going to work. Letter C, if I bring the x that's out front back up to the top, then that becomes natural log of 1/7 to the x. Well, is 1/7 to the x the same as natural log of 1/7 to the x? No, because taking the natural log of it has an effect on it, and it's keeping it the same. So that's not it. If you looked at E, -7 to the x, no, that's not 1/7. That's just the exponential growth reflected across the x-axis. That does not turn it into a decay function. So by process of elimination, you could go with D. Now, why is D correct? Well, we have to do a couple of things here, and I don't think I showed it here, but we want to bring the x that's multiplied in the back, you want to bring it to the front so that it looks like E to the negative x times the natural log of 7. Okay, multiplication is commutative. We just have 3 factors there, the -1, the natural log of 7, and the x. If we put the negative x first, now it looks like the form that we're used to seeing. We could bring that negative x up as an exponent because it's in front of a natural log, and that becomes 7 to the negative x power. And now the property is e to the natural log of blob is just the what? It's just the blob, right? That's this property. B to the log base B of x is just x. And these are both base e. And of course, 7 to the negative x, that's different than negative 7 to the x. That's the reciprocal. That's 1/7 to the positive x. And so with a little manipulation, you can verify that that one is too, indeed, in fact, equivalent, okay? So process of elimination, or just go at it, right? Or both, right? Good test taking strategies. Question, question, question. If you take the retest, this is going to be a really hard one to write as an open-ended question, right? I'd be like, write something else that's equal to that. And you might just say, oh, okay, +1 - 1. How's that? Yeah. Right? So that one will remain a multiple choice question. But I'm going to jumble the answer choices up, so it's not necessarily going to be D. Just an FYI. Okay. Okay. All right, moving right along then. Number 4, domain, domain, domain. What's up, -7? What's up, -11? Don't really care about you. Base 3, whatever. I'm just interested for domain purposes in the argument. All right? So I write it in descending order, -x² - 6x + 40, and we want it to be strictly positive, strictly greater than 0. Okay, now to factor that, since it's a negative leading coefficient, I'll just factor the negative out, which changes all the signs, makes it easier to factor. Factors a -40 that add up to +6. If you're not sure, look at some of the answer choices. They got some 10s and 4s in them, so it ends up being +10, -4. That is enough right there. We don't do anything past that, because if I said each factor greater than 0, now I'm wrong all of a sudden. But I do know because the leading coefficient is negative, the parabola opens downward, and now I have my two x-intercepts of -10 and +4. So here's a quick sketch. -10, +4, the parabola opens downward. And again, the inequality says we're looking to see where it's what? Greater than 0. That's where is it above, strictly above the x-axis. Well, that's going to be between the x-intercepts, exclusively between the x-intercepts. So that's from -10 to 4, which is, there you go, -10 to 4. It could also be written like this. Remember, in the compound inequality, it almost is the same, right? The -10's on the left, the 4's on the right. You just put your x in the middle, and then those become less than symbols. It's exactly the same thing. If the parabola had opened up and everything else was the same, now the positive values would be outside the x-intercept. So we've done this quite a bit, okay? So right at this point, it's like feeding a full horse, right? Or sawing sawdust. Sawing sawdust. All right. Make sure you know how to solve quadratic inequalities by graphing. It's either between or outside of the x-intercepts. Okay. Which of the following is the inverse of this? Okay, inverse. How do we find inverses? Switch x and y and then solve for y. Yeah. So f of x is the same as y. So that's my first step. I'll just call f of x y. And now here's the switch step. Y becomes x, x becomes y. And now to solve for y, the first thing I'm going to have to do to get the 5 to the y by itself is divide both sides by 3. So I get x over 3 equals 5 to the y. And then this is where some people got stuck, right? You could take the log of any base of both sides, but if you notice, your answer choices are all base 5, which is the logical choice because it's exponential base 5. So if you take the log base 5 of both sides, this is what it looks like. It looks just like that, okay? And of course, on the left, log base 5 of 5 to the y's power becomes y. And on the right, we're just left with log base 5 of x thirds. So now that it's solved for y, we can just rename y as f inverse of x. And we look for that as an answer choice, and it's answer choice E. There you go. All right. So any questions on that one? All right. Number 6. We have log base 3 plus log base 3 equals log base 3. So this is kind of like the warm-up, except they're already log base 3. We need to condense. So on the left, they're both positive terms. So we pull 1 log base 3 out, and we multiply the arguments, x plus 3 quantity times x. Once you have that, you have log base 3 of something equals log base 3 of something. You can either exponentiate both sides, base 3, and get rid of the logs, or you can use the property to get the bases the same. The logs just drop out, and then you can equate the arguments. So if you use the theorem, that's where the word so comes in. If you were to not use the word so, you would probably want to show 3 to the, 3 to the, and then get to the same line. Okay. So now, How do we solve something like this? Well, we have to expand it out, collect everything on one side, and then try to refactor it. So x squared plus 3x minus the 28, now it's equal to 0. Factors of negative 28 that add up to 3, 7 and negative 4. Wow, isn't it amazing how all these things just work out to be such wonderfully nice integers? Yeah, you're welcome. Okay, so I get two answers, negative 7 and 4, both of which are answer choices. And so you're like, if they both work, how do I answer twice? Well, no, you check them, right? If you plug in a negative 7, you get negative 7 plus 3, which is negative, who cares? Plug it into x, you get negative, who cares? So the negative 7 ends up being extraneous. When you plug in the 4, you get positive, positive. So it's just the 4 that works. It's answer choice B. Now, maybe a better question here would have been, which of the following are solutions? And I could have done the old multiple choice test question. Part I could have said x equals 4. Part I could have done x equals negative 7. And then I could have said x equals, give me another number. 513. Good. Nice. Okay? And then your answer choices would have been I only, I only, I only, or I and I, right? And how many of y'all then would have taken I and I? You don't have to say it out loud, okay? Because you didn't check your solution. So that would have been a better question in hindsight, right? Hindsight's 2020. Okay. Number 7, solve by getting the bases the same. Oh boy. Of all the getting the bases the same problems that we worked, this was probably not the hardest one, right? It looked pretty manageable. So what base are we going to use? 5, right? So 1 over 25, that's 1 over 5 squared. Bring the 5 to the top and call it 5 to the negative squared power, and it's still to the x plus first power. So that's baby steps. On the right side, the cube root of 5 is just 5 to the 1/3, and then that's raised to the 2x power. Now we have to multiply because we're exponentiating. So here's where we distribute. 5 to the negative 2x minus 2. And then here we multiply straight across. That's 2x over 3, or 2/3 x. And just like with the logs a little while ago, now we have the bases the same for exponentials. So now we could drop the bases and equate the exponents. So negative 2x minus 2 equals 2/3 x. Again, notice the word so because I used the theorem. Now, at this point, you could have multiplied both sides by 3. That would have cleared out the fraction. Some of y'all did. I, however, embraced the fraction. So I brought the 2/3 x across. It became negative. Took the 2 to the right side. It became positive. So minus 2 minus 2/3. Well, 2 is how many thirds? Multiply by 3 over 3, and you get 6/3. So minus 6 minus 2 is minus 8/3 equals 2. And then you multiply both sides by the reciprocal of negative 8/3, and you get x equals 2 times negative 3/8. And, of course, when you multiply that, you get negative 6/8, or simplifies to negative 3/4. And is that an answer choice? I hope so, right? I felt good on that one. Oh, there it is. It's answer choice A. Answer choice A. It's there. Okay? So if you missed that one, maybe it was way up here when you distributed the negative 2. You didn't distribute it to the 1. Maybe you just called it negative 2x plus 1 or something. I don't know. All right, then this one, what is the constant percentage decay rate? Man, this goes way back to like the very first part of this chapter. It is exponential decay because the base is 0.94. But remember, what this tells us then is we are retaining 94% each cycle. 94% retained, 94% retained. So remember, if it's less than 1, you have to subtract that number from 1 or convert it to a percentage, 94%, and subtract it from 100. So 100 minus 94 is 6%. We are losing 6% every integer value of t because we're retaining 94. And there were a lot of other handsome choices, right? 0.6, 0.06, 6%, 0.8, 94, 0.94, but it's right. Good. Any questions on that one? Okay, and then finally, the last one we did in the notes was using the change of base formula to get from one graph to another graph, but you didn't even have to think about it like that because I set the equation up for you. But normally we would take the equation we're starting with, throw an a in front of it, which allows us to stretch or compress it vertically and flip it across the x-axis if need be, to get the other graph, which was log base 7. So they're both growth, which is good, so we don't have to reflect it. But all we got to do is solve for a, and it says to use the change of base formula. So what I would do first is divide both sides by log base 2 of x, right? Divide both sides by log base 2 of x. And then you've already solved for a, right? So in one step, you've solved for a. But that's not an answer choice, right? So now we got to use the change of base formula. If you look at most of your answer choices, they're in terms of natural log. So when in doubt, natural log it out. So the numerator is natural log of x over natural log of 7. And then all divided by, notice the big division bar. Don't lose sight of the big division bar. There he is. And then the denominator is natural log of x over natural log of 2. And of course, we don't like complex fractions. So in this case, you can lick them over lick them, or because it's a single fraction, you could stay, change, flip, which is what I did. So the numerator stays, division bar becomes multiplication, flip, and then your natural log of x is divide out. And of course, that leaves you with the natural log of 2 divided by the natural log of 7. So kind of feels like the very first question on this test. Natural log of 2 over natural log of 7. Is it there? Oh, there it is, right? No, see, that's the one that Mrs. Lincoln was trying to type up on the other one. The natural log of 2 over the natural log of 7 is not the natural log of 2 sevenths. Then I guess it's not there. That's the best. That's the closest, right? Well, let's see. We'll convert it back, right? Using the change of base formula again. Since the 7 is in the bottom is the base, and the numerator is the argument. So it's log base 7 of 2. And that is answer choice D. Yeah. Okay, there you go. Any comments or questions on that? All right, moving on to the free response. Okay. Step 1, put it in the standard transformation form. So here we go. The 7/5 in the front goes to the back. Oh, by the way, I'm getting really, really irked when I grade some papers and there's no f of x equals, okay? I haven't started taking off yet, but I think I'm really close to that point where I will, okay? So f of x equals, the 7/5 goes to the back, so I threw them in the back. The 3/4 is your a value, the natural log. So really the only thing we need to do is the inside. So I'm going to do that in 2 steps here. I'm just going to go off to the side. That's negative 4/3 x plus 8. Right? That's just commuting the 2 terms. And now whatever the coefficient is of x, I'm going to factor it out. Negative 4/3, parentheses, that's x. Now here again, some people are getting this confused. A lot of people had 1/6 there. Don't do that. We are dividing out a 4/3 from 8. We are dividing out from 8. So that's the same as 8 divided by negative 4/3. That's what that is. What we started with divided by what we're factoring out. Let's do the stay, change, flip thing. 8, change, and then we get negative 3/4. And then we'll put that over 1. And remember, for multiplication, you multiply straight across. Or you could divide first. 8 divided by 4 is 2. 2 times negative 3 is negative 6. Or you can go straight across. 24 divided by 6 is 6. So that's negative 6. Not 1/6, negative. Now, I kept the negative there, but you could have also realized it changed the sign. Now, real quickly, before we proceed, what can we do before we proceed just to make sure? Redistribute. Negative 4/3 times x is negative 4/3. What is negative 4/3 times negative 6? Well, let's see. Multiply straight across. That gives you positive 24 divided by 3. That gives you positive 8. Is that what we needed? Yes. Okay. So that's really elevating that step to a whole new level of importance. If you're not getting it right, focus on that. Okay, so there it is. That was one check. One check. Find the simplified exact value of the y-intercept. It's easier to plug into the original one because really the only reason we want it in standard transformation form is for graphing purposes. But I didn't care which one you plugged in. But I did look for f of 0. That's 7/5 plus 3/4 times natural log of 8 minus 0, which is just 8. Okay, so that was the second check. You had to have f of 0 there. For what it's worth, a couple of people did this as well. That's greater than 0 because the natural log of 8 is positive because 8 is bigger than 1. Remember, the natural log of anything between 0 and 1 is negative. Anything bigger than 1 is positive. So a positive times 3/4 is positive, and a positive plus 7/5 is positive. So that could be helpful later on, but you didn't have to put greater than 0. All right, and the next part, sketch the graph. Okay, well, here's where the wheels came off for some. Our parent function is y equals the natural log of x. Does the natural log of x have a vertical or a horizontal asymptote? It's a vertical asymptote, right? And it looks like this. So if you don't know your parent functions, that's not good. All right, and I told y'all in class there's an easy way to remember it because the L in log looks like a what? A vertical asymptote. Yeah. A lot of people, way more than I care to even admit, sketched exponential functions with horizontal asymptotes. Yeah, and if you do that, you're really kind of working an entirely different problem. It's going to be really hard for me to even give you partial credit for what you're doing because it's just a totally different problem, okay? So anyway, we move everything to the right 6 units, including the vertical asymptote. The negative 4/3 reflects it across the y-axis. So if you take this log function and reflect it across the y-axis, it looks like that. We don't really concern ourselves with the stretches or the dilations. So this graph is going to be a decreasing function, and it's going to live to the left of its vertical asymptote, which is shifted to the right 6 units, okay? So there was 3 checks here. One check is for having a vertical asymptote at x equals 6. Not just any vertical asymptote, but a vertical asymptote at x equals 6. Another check went to, is your graph to the left of a vertical asymptote? So notice if you have a horizontal asymptote, you've already lost both those checks. And then the 4th check was, is it a decreasing function? Now that's the one that some people who did exponential, who did it like this, I was nice, and I gave them a check for having a decreasing function. But that was the other check, okay? Now notice I have it crossing in positive land because I've already determined that. If you didn't check, as long as it crossed in the right spot, I assume that you checked and did it very deliberately. Okay? Good. So that's the graph. One check for each of those. Now you could have recovered if you had a log function, but you had the vertical asymptote in the wrong place. You could have recovered, and I'll show you where. The next one, find the domain. Most people went up to their graph, and they got the domain right off their graph, which is fine if your graph is what? Correct. It is everything less than 6, okay? Or negative infinity to 6, okay? You could not recover just because you had the right domain from your graph. Why? Because you can always find the domain algebraically. You should have done that. Get in the habit, okay? Take your argument, 8 minus 4/3 x, from the original problem and say it's greater than 0. That's a linear inequality, so we could solve it algebraically. Bring the 8 across, multiply both sides by what type of 3/4 or 4th? Yeah, 3/4? Negative, so that flips the inequality, and you end up with x is less than 6. Once you do that and you trust your math, you compare it to your graph. If your graph is not to the left of 6, something's wrong. You probably flipped it the wrong way, you shifted it wrong, something, okay? So you could have checked your domain algebraically. So I didn't just let you have the domain of your graph. All right, the range, all real numbers all day long. That's an easy one, okay? All real numbers for any log function. Notice for an exponential, you got those backwards. That's a different problem. So here's where you could have recovered. Find the equations of any and all asymptotes. Be sure to label which type. As long as you had a vertical asymptote from a log equation, I went ahead and gave you credit if you put VA at x equals, not y equals, your x value from your graph, if it was labeled. Some people had a vertical asymptote at -6. Some people had a vertical asymptote at 1/6. This is where you could have recovered if you did that. But again, I was hesitant to do that because the vertical asymptote is closely related to the domain, which again you could have verified algebraically. Okay, and then this one was really hard to get if you had the wrong graph. The limit as x goes to negative infinity. So if you look at the graph here and you head out to the left, it goes up forever and ever and ever and ever. So that's positive infinity, or I accepted D and E. Okay, now if you had a function that was doing this accidentally, then I looked at your graph and you would have said negative infinity, I would have given you credit for it. Okay, if you had an exponential function and it went with something like that, then I went ahead and said, oh, okay, your graph went up to negative infinity, so I let you recover on that one too. Most people who kept it safe, they did D and E. Okay, now if your graph is living like this, let's say you had the graph living right here. Do you think I'd ask you what the limit is as x goes to negative infinity? No, it is D and E, but it's because the graph doesn't live there. So I would not likely ask that on a test. So if you see yourself answering that type of question, that's another indication that you probably did something wrong, okay? But D&E would be correct, and some people did that, and I said, okay, well done. All right, so there's the test. There were 9 checks on the back, 9 checks on the front, for a total of 18 again. You can always calculate your grade, raw score. Take the number you got right, divide it by 18, multiply by 100, and compare that to the score I gave you, okay? So when is the retest? Tuesday. This video is in the shared folder. You can watch it 100,000 million times, okay? No, the test is yours. Just, keep them guarded. I do have a retest version out there already, but again, don't help anybody get a better score than you got.